Hello, period 4. Proportion notes. Alrighty, go ahead and fill these in as I go through these. Let's talk about the definition of a proportion first. A proportion is an equation stating that two ratios are equal. So something is proportionate if the two ratios are equal. Okay? Or we can say two quantities that form a proportion are proportional. Okay? Alrighty. This next proportion is read like this. 2 is to 3 as 4 is to 6. Kind of like an analogy. Mrs. Defendants would be so proud of us. So 2 is to 3 as 4 is to 6. These are proportional. 2/3 is the same as 4/6. They are in proportion. Okay? There are 3 ways to tell if two ratios are proportional. And it depends on the numbers which way we will decide to figure out if they're proportional or not. Okay? So, first way to figure out if ratios are proportional is to just reduce both fractions. So if I simplify, reduce, break down, whatever we want to call it, 8/10, that would simplify to 4/5. Agreed? 20/25, if I simplified 20/25, I would get 4/5. Since both of those fractions reduce to 4/5, we would say yes, those two fractions are proportional. Let's reduce the second set. 14/20 would reduce to 7/10. 5/10, we could simplify that or reduce that to 1/2. Is 7/10 proportionate to 1/2? No, it's not. Those are not proportional. Those are not the same. Okay, so there's the first way to see if two ratios are proportionate, is to reduce the fractions. Second way, find a common multiplier. Okay, a common multiplier. So you're asking yourself, how do I get from 5 to 15? You multiply by 3. If I multiply the bottom by the same number 3, does it make sense? 6 times 3 is 18. Yes, so those two are proportional. So we'd say, yes, they are in proportion. 5/6 is equivalent to 15/18. Let's look at the second one. To get from 4 to 8, I multiply by 2. If I do multiply the 10 by 2, would it equal 15? No, it would be 20. So those are not in proportion. Okay, so a common multiplier is the second way. Okay, real quick, use caution because the common multiplier can be a decimal and you would not recognize it. Okay, 12/18 and 14/21, you don't necessarily have a common multiplier there. I wouldn't use a common multiplier on this one. I would just simplify these fractions. So I wouldn't even use a common multiplier. I would, let's divide that by 6 to get 2/3. Let's divide this by 7 to get 2/3. Those are in proportion. Okay, I wouldn't use a common multiplier. Over here, again, there's nothing easy peasy to multiply using that, so I wouldn't use that. I would simplify and get 4/5. I would simplify and get 4/5. Those are both proportional. Okay, so that's what I was talking about earlier. It depends on what your fractions or what your ratios are. I should say ratios, not fractions. It depends on what your ratios are, depending on what you're going to use. If you're going to reduce them, if you're going to use a common multiplier, or the third way is to use cross products, okay, cross multiplication. So if you can't use a common multiplier, no clue there. If the fractions are already in simplest form, you can use cross products. 7 times 4, 28. 5 times 5, 25. Is 28 and 25 the same? No. Those two ratios are not proportional. Okay. Same thing here. I'm not going to use a common multiplier. They're already in simplest form, so I can use cross products and say no, they're not in proportion. Okay, so those are the three ways to determine if two sets of ratios are proportional: reducing the fractions, finding a common multiplier, or using cross products. Okay, so I'll do the next three with you, and then you can pause the video and do 4, 5, and 6. So again, it really doesn't matter what you choose. If you're best with simplifying fractions, go for it. I wouldn't use cross multiplication on this one because it's going to take some time to sit there and multiply, okay? So I see right off the bat, I can get from 6 to 24 by multiplying by 4. 4 times 4 is 16, not 18. So I automatically know those are not in proportion. Now you could have also simplified 2/3, and over here, let's see, would be 3/4. Again, 2/3, 3/4, not the same. So it doesn't matter which way you choose, as long as you know they're not proportional. Okay, 4, 6, and 18, 20. Okay, so we just did this one. Okay, I think I wrote it twice, so I would do one way with reducing and the other way with a common multiplier. Again, not the same. I already showed you both ways. Okay, so what about this one? I don't see a common multiplier, so I would just simplify. So I'm going to divide numerator and denominator by 5 here to get 5/4. 3 here, 3, 6, 9, 12 to get 5/4. Yes, those two are in proportion. They're both 5/4. Okay, all right, go ahead and pause. Do 4, 5, and 6. Don't just give me a yes and no. I want to see you simplifying, or I want to see your cross products, or I want to see your common multiplier. Do not just give me a yes or no. Show me your thought process. Okay, on number 4, 4 times 2 is 8, 6 times 2 is 12. Those two are in proportion. You at least need to show me some sort of work. Over here, I can't think of a common multiplier, so I'm just going to divide 9, would be the GCF, wouldn't it? 9 goes into there twice, 9 goes into 27 3 times, 11 goes into there 3 and 4 times. 2/3 and 3/4 are not proportionate. So again, I need to see your thought process. I used simplifying or reducing. And over here, I don't see a common multiplier. I'm going to simplify this one. That one's already simplified, so I can't really simplify. Let's go this way. Let's say this is 40, and this is 44. Those are not in proportion. Okay. Alrighty. Number 7, how do you know these are not proportional without doing the math? 10/3, 5, 6. What about 10/3 do we recognize? That's improper. So 10/3, this is larger than a whole, right? 5, 6 is less than 1 whole, okay? So we already know without doing anything that those are not in proportion, okay? Be careful, because if you were looking at common multiplier, this is times 2, this is divide by 2. Those are not the same thing, okay? Okay. Last little bit of notes here. What about this? Now these are tables. are X and Y proportional? Okay, so X and Y, are they proportional? Here's the easiest way to do this. Again, choose one. 2 to 7, is it equivalent to, I'll do down here, 5 to 10. You could have chosen any one. I don't see a common multiplier. This could be simplified to 1/2, or I could do cross products, 20, 35. Those are not in proportion. 2 7s, 3 8s, 4 9s, 5 10s. We can see that those are not in proportion, okay? So again, on the tables, just choose any two ratios, and you can do common multiplier, reducing, or cross products. So again, I could do 2 7s, and I could do 3 8s. Okay, either one. If I do cross products, I get 16 and 21. This table is not in proportion. Let's look at B. Are X and Y proportional? So let's say 2 to 3. Is that proportional to 4 to 6? Times 2 times 2. Yes, it is. Or we could do 2/3 and 6/9 times 3 times 3. This table is proportional. Okay. Alrighty. Last four, we're going to solve for X. Easiest way to do these. How do I get from 6 to 18? Multiply by 3. Do the same up here. So X is 15. Next one. How do I get from 4 to 32? Times 8. So do the same down here. 5 times 8 is 40. Let's look at the next one. This one, pay close attention. How do I get from 3 to 24? Times 8 something times 8 is 16, or go the inverse. 16 divided by 8 is 2. 2 times 8, 16. 3 times 8, 24. So you kind of have to make sure you're thinking correctly if the X is on the left side instead of the right side. Same thing with this one. 5 times 3 is 15. Something times 3 is 21, or do the inverse. 21 divided by 3 is 7. Alrighty. All right, guys, there are your notes. Check